Building a tight regression model in Excel is critical for accurate land value. Watch raw data transform into a razor-sharp prediction tool with 87% accuracy.
This is a really direct and easy way to refine comps from any data set. I have the data arrayed here from smallest to largest in the first column. And we have the X independent value, the money, in the column to the right. This is where you want to have the data to create a scatter plot. So let's create a scatter plot with this data. Here's the resulting scatter plot. Now, from the entire 220 data points that we have, you can see that the relationship of land value to site size is inversely proportionate. However, the spread is quite significant. And what we need to do is refine this data set so that our R squared gets above 28% into a much more acceptable range. You can see from the trend line here in blue, what we really want is to narrow this range of comps so that it's within a smaller range of dots above the trend line and those dots that exist within the small range below. And when we can refine these dots, then we'll get a much higher correlation and remove all of the outliers. So the first step is to measure this distance, the y hat, to measure the distance of this actual dot from where the dot should be. And this is going to represent the market performance. And we only want the ones that have a market performance that falls in line or very close to this trend line. So we need to measure each of these positions. These valuations show the dots as they are. To measure the positions, we're going to have Excel display the trend line on the chart. And we're going to use this formula in the next column to calculate the values of each of these positions. Use the parcel size, the caret to show the power, and there we've calculated all of the ideal market positions of these spaces. Next, we want to measure how far off these positions are from the positions that we have in our sales. So this is going to be a difference of the sold land value and the predicted position of the land value. And you can see that many of these numbers are negative because we have market sale positions that are below the market trend. And that's okay because we are going to be refining them. We're going to add another column now, and we're going to turn this difference into an absolute number. Because whether it's performing above or below, we're interested in the ones that have the narrowest range around the market trend. So we're going to determine the absolute value of this number. And then we're going to array the data from smallest to largest. Now notice the dots here haven't changed, just the data in the table. This is where the fun happens. We're going to leave the percentage here on the chart at 28%. And we're going to refine the set that it represents over here by dragging up the bar from the bottom up. And you can see I've already measured the point where we're going to stop. And let's see how that looks. You ready? All right, let's see how this goes here. We have it selected. And this, you can see where the data is selected on the left. We're going to go all the way down to the bottom. We're going to start by dragging it up about 20 cells. So these are these data positions have the highest amount of outlier positioning. And already we've increased the R squared up to 47%. You can see we have a little bit more clustering here around the median line. Let's drag it up a little bit more. Drag the selection up, process up, and drop more of these properties that performed the distinct deviation. Now we're up to 50%. Our goal is to get at least in the 80s, which is a measure of strong confidence. Let's take it up another 20 properties. Now we're up to 65%. You can see here the dots are really clustered around the land value. We're getting a lot closer to having a supportable model. Take it up another big group there. Now look at this. We're at 81%, and these dots are clustered around this trend line. So we now have a strong market trend with considerable amount of properties left. Let's take it up to the bar that we previously measured. And that takes us to 87%. This is a strong determinant here for land value. This is solvable now. And if you see here, we still have many data points. In fact, we can count them. Oh, we have 80. So we have 80 data points making up this land valuation. This is going to be pretty easy to determine now what our land value is. So we've turned back on the formula here to solve for y. And we've added that back in so that we can plot a subject size. And now here on this grid, we have our 80 data points aligned and tuned to 87%. We have our formula for solving them there on the grid. So with the formula turned on, we can calculate in this formula what that's going to be. Use our site size as the variable. All right, we turn the formula back off. And then we enter a site size in here, 0.16. Let's change the currency to money. And you can get a nice, easy measurement here of land value with 80 comps. Once the model is put together, if you need to change the site size, you can, and it will calculate value of land for any parcel within this range to a very specific number. That's all for today. Thanks for watching.